Hello, good morning, good afternoon, or good evening, wherever you are on this beautiful planet of ours. Welcome to Sustainability in Your Ear. This is the podcast conversation about accelerating the transition to a sustainable, carbon neutral society, and I'm your host, Mitch Ratcliffe. Thanks for joining the conversation today. We're going to talk about food. Food is responsible for roughly a quarter of global greenhouse gas emissions each year, and the climate is now responsible for a growing share of what happens to our food. Food systems face dramatic challenges. Droughts are reshaping olive country in the Mediterranean. Warming oceans are increasing the frequency of shellfish pathogen outbreaks. Hurricanes are taking out manufacturing facilities. Sea level rise may flood key ports where food flows. And fluctuating precipitation is driving mycotoxin contamination in crops, and that's only a partial list. The food system must feed 8 billion people while the conditions it was designed for are unwinding underneath it. Meanwhile, the public conversation about food and climate gets stuck at the two ends of the chain, agriculture on the one side, consumer choice on the other. But our guest today wants us to pay attention to what happens in between, the processing, packaging, distribution, and storage that turns a fall harvest into something you can eat in February. That middle segment is where a quarter century of food science meets the climate problem and where most of the practical levers actually live. Brendan Niemira is the Chief Science and Technology Officer at the Institute of Food Technologists, a Chicago-based scientific association that has served as the voice of the global food science community since 1939. Its 200,000 member network spans academia, government, and industry, and he stepped into this role on December 1st, 2025, after more than 25 years at the USDA's Agricultural Research Service, where he led a team of 30-plus scientists, engineers, and students developing tools to kill foodborne pathogens on produce, meat, poultry, and shellfish. Brendan's specialty is non-thermal food safety systems that use cold plasma, high-intensity monochromatic light, irradiation, and pulsed light treatments to disinfect food without cooking it. He's published more than 200 peer-reviewed papers, holds patents on the technology, and the 2024 citation rankings place him in the top 0.01% of food scientists worldwide. Brendan joins the IFT at a moment when food science is being pulled in two directions at once. On the one side, climate pressure on supply chains, food safety, and resource efficiency is intensifying. The subject of IFT's new white paper, Food Science and Technology Solutions for Mitigating and Adapting to Climate Change, lays out a roadmap for circular bioeconomy practices, AI-enabled supply chain resilience, food waste valorization, and emerging technologies like cellular agriculture and precision fermentation that is growing food in vats. On the other side, the public and political conversation about food is fixated on ultra-processed food, and the MAHA Commission, that's the Make America Healthy Again Commission, frames processing itself as the central problem rather than part of the solution. IFT has been one of the loudest scientific voices arguing for definitions grounded in nutritional quality rather than processing intensity. That's a position that's both scientifically defensible and complicated by the fact that IFT's membership includes much of the food industry. So we're going to talk with Brendan about what the climate case for a redesign of the food system is, what IFT's recent white paper does and doesn't quantify, and where precision fermentation and cellular agriculture actually stand in 2026. We'll also look into why food safety remains under-researched within climate science and how IFT is navigating this MAHA debate. To learn more about IFT's work, visit ift.org, and the white paper we'll be discussing is available there as well. The climate fight runs through the food we eat, but most of the action is happening in the part of the supply chain that nobody sees. So let's find out what Brendan Niemira sees right after this brief commercial break. Welcome to the show, Brendan. How you doing today?
I'm doing great, Mitch. How are you?
I'm well. It's a beautiful morning here in Southern Oregon, and I'm excited about this conversation. You spent 25 years at the USDA. What does the food system look like from this new vantage point at the IFT? How's it different than the perspective from the lab bench?
Sure. Well, first, let me say that, I really enjoyed being a scientist for the USDA. There were a lot of great scientists working at the USDA, and I was absolutely proud to be one of them. Even with the recent losses of scientists, engineers, and subject matter experts in different areas of the federal research continuum, the research done in those labs remains a crucial part of
Yeah.
the overall science landscape for the U.S. And so my work as a food microbiologist with the USDA's Agricultural Research Service was focused on food safety and
Mhm.
advanced food processing technologies. And that was, again, to improve food safety and extend shelf life. So now, as the Chief Science Technology Officer for IFT, I get to engage with all of the technical areas of food science, microbiology, chemistry, sensory science, sustainability, food laws and regulations. And then I also get to engage in the larger space, kind of around advocacy and science communication.
Mhm.
So I get to work with colleagues across the whole food system, from all the way from primary producers like farmers and ranchers to processors, product developers, all the way to nutritionists and retailers. So I get a much bigger picture view.
When you think of it from that perspective, but from the industry side, what do you think the key issues that we need to consider as a nation are in our food system as it stands today?
Food has to be safe, healthy, wholesome, but it also has to be available. It has to be sustainable, and it has to be the kind of food that people will want to eat. Right? It doesn't matter if you produce something which is super healthy and even super affordable, but if it doesn't meet the cultural needs of what people want to eat, if it doesn't meet their expectations for how it looks, how it tastes, how it performs in their lifestyle, then it's going to stay on the shelf. And all that science that you did to produce this product is not going to be any good because it's not going to provide any nutritional benefit for people.
The IFT draws a sharp line between food processing, what you do to the ingredients, and food formulation, which is the ingredient list itself. Why
Yeah.
does that distinction matter? And why has the public conversation lost that distinction?
Well, so we draw that distinction because if you take either one of those aspects alone, just the ingredient list or just the degree of processing, neither one of that is going to give you a complete indication of the healthfulness or the nutrient value of the food. I mean, and if you use either one just as a simple shorthand, you say, well, there's a certain thing that's on the list of ingredients or a certain thing was done to that stuff, you miss the mark. All right, you're going to have to take both of them into account to look at the total healthfulness of the food. And part of the issue with the public conversation is that frankly, it's a little bit more straightforward to give short, simple messages about which foods are healthy and which foods are not. Look for this ingredient or look for that processing step, and it's a thumbs up or a thumbs down. And that the fact that it's simple, right? Well, that simplicity is true, even if those short, simple messages don't give a complete or, frankly, a fully accurate picture. Food is more complicated than that, and complicated stories are harder to tell.
Our dialogue is, let's just say, relatively simplistic right now. Are we diverging from the real issues we need to be exploring as a nation when we talk about the MAHA concerns?
Well, because the science communication tries to make complex issues of science and nutrition, nutritional availability, even getting to things like cultural tolerance, cultural acceptability, economics, and all that sort of stuff, tries to make these very complex issues in a way that people can understand. Not everybody is a nutritionist, not everybody is an economist. People just want to be able to get food that they want to feed their family, and they want it to be safe, they want it to be healthy, they want to be able to afford it, they want to be able to provide it, and they want to be able to enjoy it, right? Food is about more than just nutrition. Food is about culture. Food is about satisfaction. Food is about joy. Those are things that simple stories can speak to, but the
Mhm.
science behind this can be very complicated. So it's the job of us here at IFT, and it's the job really of all science communicators to take these complicated issues and present accurate, factual, complicated science information in a way that people can understand and that they can use to make decisions on.
Having written about technology and sustainability and a variety of things over the years, I find that one of the challenges is that experts resort to their jargon, partly because it's shorthand and it makes it easier to say something to somebody else, but it relies on an understanding of that jargon. Are we at an inflection point? And I guess that I hate to put it this way, but is Bobby Kennedy simplifying this conversation in an important way?
Well, this is why science communication is a distinct discipline, right? Because you can be a terrific microbiologist or chemist or toxicologist or nutritionist or economist, but if you're not able to communicate to people outside of your discipline, then you run the risk of miscommunication,
Mhm.
where you're trying to say something, but you're just not communicating accurately. And unfortunately, you also set it up in a situation where people can take what you say in your good faith effort to explain it properly, but take what you said and they take a word here or a sentence
Yeah.
there or phrase things, and things get misunderstood or they get taken out of context. And then when people draw conclusions from that, stuff that is misinterpreted, then base decisions on that or policies based on that, then you can get to a point where the science is over here, the communication is here in the middle. It gets a little bit muddled, and then policies arising from that are based on something that is not directly related to what the science is actually telling you. And that's why we try to support good science communication and try to give people tools to communicate the science. So when at IFT, we bring a lot of different scientists together in different disciplines, and we try to give them the tools to make sure that people are understanding their science and can act on it appropriately.
I think that's a really important point that we need to create full access to the conversation. People who want to dig in further can go further and learn more in order to deepen their understanding of the decisions they face, either as a consumer or as a policymaker.
I'll just give a quick shout out to ift.org. We have lots and lots of information, that some of which is intended for scientists and technicians, food scientists, food technologists, and it is very jargon heavy. But we have a lot of information that is intended for the general public to consume, that is intended for decision makers in industry, academia, and government.
So, a moment ago, you talked about the food system needs to be sustainable. And a recent meta-analysis found that the processing, packaging, transport, and retail steps in the food process account for just a modest share of the overall greenhouse gas footprint of our food system. Farm production and distribution accounts for most of the rest. If most of food's climate damage is upstream, how big a sustainability lever can processing innovation actually be? Can we really lower the overall impact of our food?
Well, you're absolutely right. A lot of what the impact is done is on the primary production, and that's why people are also working on reducing the carbon footprint, water usage, and overall sustainability impact at the primary production stage: farms, ranches, fisheries. And if you go talk to groups like the American Society for Agronomy, the Crop Science Society of Agronomy, the Soil Science Society of Agronomy, the American Meat Science Association, I mean, all those folks, they are working hard. They're doing all of that science to develop and implement ways to improve sustainability in terms of, again, carbon footprint, water use efficiency, land use programs, wildlife setbacks, insect refugia, and a host of other approaches. Now, IFT does food, right? We do food processing, food science, food technology. So we are in kind of that center part of that continuum, but we are actively working with those other scientific organizations to support the work that falls under those sectors of the overall food system and to improve what we can do in our process packaging, transport, retail, and so on. Mitch, I would say this is one of those cases where we can't allow ourselves to be tripped up by the false thinking. This is what if we can't do everything, then we shouldn't do anything. Our Sustainable Food Systems Interest Group is an active and vibrant part of all the food science that we support. And so there's a lot of communication between what they are doing and what all the other efforts are underway in other societies and other parts of IFT.
Absolutely. We can't let the perfect be the enemy of progress. We have to take these
Sure.
important steps.
So here at IFT, we're doing what we can, and we are supporting the other people that are working in their areas as well.
When I read the white paper that I mentioned in the introduction, there was not a lot of quantified environmental data, but it seems to me that what you're saying is that that's an area we really need to dig into now. How do we do that?
Well, it's by talking to the people that are on the ground doing that work.
Mhm.
I would not sit back here as somebody that focuses on food production, food science, and go talk to a soil scientist and tell them what to do or what they should be
Mhm.
doing or what I think is most important in their area. I think when we're all focused on the same overall goal of improving sustainability and reducing the impact of how we grow, how we harvest, how we process, how we ship, and how we consume our foods, then we need to listen to each other. There are people who have expertise in lots of different areas. Our food is complicated. I mean, people think, well, there's an apple on the shelf or there's some hamburger in the cooler. Food is complicated. It really, truly is. And all of the different people that are contributing, all the different ways, all up and down across the food system, the food continuum, we need to draw on their expertise and get together to solve problems that will work across the entire system. I mean, if one person working on just one part of it rolls out this solution and say, "Yep, I've done my thing and all the rest of you should change to do what I want, then that may not be a viable solution because it breaks other parts of the system. There has to be a holistic approach.
As you say that, I realize how hard it is just to get food from my garden at the beginning of the season into my onto a plate at the end of the year.
Yeah, and that's encompassing. There are different people who grow different products, different commodities, different regions, different whatevers. You grow different kinds of tomatoes in different parts of the country, and there's different ways of growing food. And it even on a very, very small scale, it gets to be very complicated. You have to have a lot of different kinds of knowledge, a lot of different kinds of infrastructure, a lot of different kinds of expertise and equipment and so on. Plus, you have to comply with different regulations, different laws controlling different sorts of commodities in different parts of the country at different times of the year. All of this knowledge has to come together and has to be brought to bear on that problem.
Again, it's a huge storytelling problem, but we have to look at this as a system rather than a bunch of separate parts that don't necessarily interact with everything else.
Absolutely, absolutely. It's all one, and that's why we talk about the food system and the food continuum, because going right from primary production through all the various stages of getting food to you, and then on the backside, go taking food waste, say, away from
Mhm.
restaurants, either point of sale, point of service, point of consumption. Some of those aspects of where does the food go, and what kind of advantages can we gain from paying attention to where those nutrients are ending up.
One of the other, and probably the most shocking part of the white paper that I read was how our dietary recommendations are being undercut by climate change. For instance, Mediterranean diet is recommended. It consists of olives, olive oil, tree nuts, but those come from regions that are warming 20% faster than the rest of the globe. How should we think about U.S. dietary guidelines in terms of how climate stress is going to change the availability of food over the course of the next decades?
I think it starts with a clear-eyed understanding of what it takes to grow, deliver, and consume food, right? So
Mhm.
if you're saying, well, I'm going to, lean into one kind of a diet or another, whether it's the Mediterranean diet or you're going to lean into other specialty diets that you either recommended by your doctor, by nutritionalist, or recommended by, your own sort of, cultural or societal predilections, where does that food come from? I mean, does it come, you talk about, is it grown locally? Is it
Mhm.
shipped far away? Does it come from other parts of the country? Does it come from other countries? And then you have to understand, well, this is what food costs. Not just the money, but it costs in terms of the carbon that you're using to produce the food, the water, the land use. Once you have that accurate information and you have an accurate understanding of what goes into producing the food, then you can start to make some other decisions about, the health and nutritional benefits of the food that you're consuming are one aspect of it. And then you can make other decisions about the other sustainability parts of how you're getting your food and how you're eating it.
You mentioned the cuts that we've seen in federal research recently. As a microbiologist, where do you think federal climate health research should be focused at this point?
Well, so my specific work with food microbiology was in food safety,
Hmm.
and so I was always very concerned with understanding the risks for human pathogens on foods. I mean, despite the best efforts of food producers, you still do have instances where you have E. coli or Salmonella or Listeria on one commodity or another. So the way that you respond to that is, I mean, there's a couple of different things you can do. You can there's sort of a three-legged stool of responding to a food safety stuff, right? From a microbiology and food safety thing. You can either prevent these harmful organisms from being on your food commodity in the first place. That's
Hmm.
called exclusion. And that's where you do, water quality monitoring, and you do land use history analysis, and you do exclusion things to make sure that the bad bacteria or viruses or parasites don't get on the food in the first place. So then you've got, so that's exclusion. You also have containment, and that's a
Hmm.
monitoring system. That's where you do continuous testing of foods that are being produced at point of production, point of packaging, when they're in the shipping. Sometimes you pull these samples, you hold them back a little bit, you check to make sure there's no pathogens that are on there. And then if you find those, that's when you do the recalls and you do
Mhm.
traceback analysis and you do traceability. I mean, our Global Food Traceability Center at IFT is working very hard to develop protocols so you can say, hey, if we have a problem, we need to know where it came from so that we can trace that back and we can isolate that and we can understand, you kind of contain that, right? And then the third leg of the stool is eradication. And that is to
Mhm.
say, you apply techniques and technologies that will eradicate potential organisms. I mean, in a big, one big way, heat, right? So if you've got ground
Yeah.
beef, you can cook that ground beef and you apply
Mhm.
a thermal process that kills any potential things like E. coli or something that might be on it. Now, heat is one technique, but you can't apply that to lettuce, right? That doesn't really work, which is why my research and other people are working on other kinds of processing technologies that you can apply to more sensitive foods. Fresh fruits and vegetables, berries, melons, other sorts of more sensitive stuff, different kinds of novel sanitizers in the organic space, non-thermal processing technologies, other sorts of interventions that will kill the organism so they can't cause any harm. So you've got exclusion, containment, and eradication. And all these different efforts working together, those are the kinds of research that you're going to do to have a good food safety impacts.
Well, because exclusion is getting harder because of the rising temperatures globally, encouraging the growth of more pathogens, or at least the propagation of more pathogens, it sounds like that's raising the bar for containment and recalls.
Yeah, if you find yourself in a situation where one of those things are not an option, or you're not able to do it as well as you were before, then you lean into the other two. If effective technologies for eradication don't exist, well, that's where you need to put some research dollars in to create them. I'll give you an example. Years and years ago, we had lots and lots of outbreaks on sprouts, right? Sprouts
Yep.
were at the cost of continuous outbreaks again and again and again. And research was put into place to find, well, how can we eliminate E. coli and Salmonella on sprouts so they can, be as safe and healthy and wholesome as they can possibly be. But just because we were working on eradication steps does not mean we were also ignoring the other two. So there were things like seed certification
Hmm.
processes to make sure the seed coming in to these sprouting facilities is as healthy as it could be. There was containment efforts to say, well, let's do better traceback analysis. Let's do better testing analysis so that we know what's on there so we can act when we find it. So it's not a case of, well, we're just going to work on one and ignore the other two. You got to have this understanding of what the problem is so you can address all the different aspects of science at once. And I would say this is one of the issues that happens when you start to see cuts in science is then you have to start making some these hard decisions. Say, well, we're going to dial back on one, and we're going to keep our remaining resources
Hmm.
and go into one of the others. Maybe you're leaving yourself in a situation where 2 years from now or 5 years from now, you might say to yourself, "Darn, I really wish we'd been working on that."
Do you think that the private sector can step into the gap that has been opened, or are we really at a point where we need to seriously reconsider our federal funding for food science research?
Well, private funding has always been a huge part of,
Mhm.
corporate funding has always been a huge part of food science research. Companies funding their own research and then funding through grants and consortia, funding larger works. Industry funds, provides grants for academic researchers, and academic research is a huge part of this. Government research is a huge part of this. And in a time when you're looking at this research funding that is cut or is under threat, and you might have these unwanted outcomes to say, well,
Mhm.
there's research that's not being done. I mean, some of our advocacy priorities in IFT is to see that we want food science research, including food microbiology, food safety, food toxicology, whether it's chemical toxicology, chemical safety issues, or biological safety issues. We want to see that funding, we like to see it increase, honestly, but at least we'd like to see it not cut. Okay. Because you can't have good data without good science, and you can't make good decisions without good data. So if you want to be able to make good decisions and develop good policies, you need good data. And for that, you need good science.
We certainly have had a foundation of solid data in the United States for the past 50 years. I think we've got a great sense of the problems that we need to talk about. Let's take a quick commercial break, folks. We're going to come right back and talk more with Brendan. Welcome back to Sustainability in Your Ear. Let's get back to the conversation with Brendan Niemira. He is the Chief Science and Technology Officer at the Institute of Food Technologists, a 200,000 member network focused on food production and safety. Brendan, let's talk about bugs. The paper discusses a Costa Rican study where they're taking a variety of food waste to farm edible insects. What's the realistic potential for adoption of food made with insect protein in the United States? Is there a path even to regulatory approval for that in this day and age?
Well, okay, so here's the thing, Mitch. I actually just wrote a book chapter on edible insects and digging
Hmm.
into all of the ins and outs and all this. So I just happen to have a lot of this fresh in my mind. Um, there are only a very small number of animals that we can take things that humans can't eat, like cellulose. Okay, humans can't eat grass. Humans can't digest grass or the cellulosic material. And historically, the way that we have made cellulose into something that we can eat is to feed it to an animal and then eat the
Hmm.
animal, right?
Hmm.
And right now we do that with cows and other ruminants. But so if are you going to do that with cows? Or are you going to do that with crickets? Well,
Hmm.
crickets have some advantages over cows. They use a lot less space. They have a shorter generation time, so you can be more responsive to market changes. They use less water. They use less energy, and so on. But then at the end of the day, you have this insect protein. And what's the realistic prospects for that? I would say that because of the cultural nature of Western society does not have a cultural heritage of entomophagy, eating bugs, right? That's
Hmm.
the Greek word for it. There are other parts of the world that do have a cultural heritage of this, and so they have lower barriers or lower sort of cultural issues with having insect proteins as part of the diet, either as just edible insects, as a commodity, where you look down and say, "Hey, here's a cinnamon crunch flavored cricket." Okay, I mean these are products that are on
I've
the
tried
menu.
these. They're not the worst thing in the world, but they're also
Yeah,
not something that most people would pop in their mouth at a movie theater.
well, certainly not in the U.S. and not, I would say, in most of the people, Western, in Europe or most
Hmm.
Western societies that derive their cultural heritage from Europe. So if you're not going to have these things that are identifiable as an insect, could you have insect protein powder
Yeah.
as part of an insect supplement? I think these things are still in the market. I mean, I have tried it. I mean, I've got insect powder and put my money where my mouth is. I've made brownies and cookies with cricket powder. Yeah, they taste like brownies and cookies.
Hmm.
It was okay. As a large scale process, I think you have to start with the cultural issue and the kind of consumer issue, because if you're going to make a product that I don't let's generalize, let's say nobody, let's say a very few people want to buy it. It's a very, very niche product. Then you are going to have that process remain a niche process. And so the
Hmm.
overall impact of it on large issues of sustainability or carbon usage or are moving away from conventional animal or plant sources of protein is going to be kind of limited. Where you might see much more of a penetration, however, is in taking these animal insect, protein sources, and use them as feeds for aquaculture. Right now, you
Oh, okay.
have fish, are not really able to digest soybean meal very well, and so you can't raise fish the same way that you raise cows and chickens. Um, but they're trying to work to breed new kinds of trout, let's say, that are better able to use soybean meal so you can get some of those economies of scale. But if you can lean into the insect protein production thing, you essentially use the insect farms, I mean, almost as a kind of bioreactor to
Hmm.
turn cellulose, indigestible cellulose, into a digestible form of protein that can be then processed through aquaculture or chicken farms or so on, animal agriculture, conventional animal agriculture, that then would go into the human feed supply. I think it is still kind of a long ways away, at least in the United States, from a time when insect proteins are going to be a significant or a major part of our daily diet. The FDA rules on insect proteins and edible insects right now are that they have to be safe and wholesome. They do have to be tested for human pathogens and so on. These insects have to be in a production facility that is dedicated to that production. They cannot be wild caught. So you
Yep.
can't just, go out into your local meadow and swing a net and start collecting crickets. They have to be
They
grown.
might be contaminated with
They,
pesticides.
pesticides, who knows? I mean, there might be other pathogens on them. There might be
Hmm.
fungi on them. There might be
Yep.
potentially heavy metal contamination. So these have to be grown in a dedicated production facility. So the FDA is certainly on the ball in terms of having an understanding of the potential risks for some of these things, and they have put rules in place to make sure that if insects are produced as human food, that they adhere to safety rules and regulations.
It's a really the metaphor of the insect as a bioreactor with legs. That makes a lot of sense to me. But precision fermentation using bioreactors is another one of the paper's big bets. And I've personally been involved in trying to raise some funding to create dairy proteins using acetate fermentation, which would reduce the need for concentrated animal feeding operations, so dairy's environmental impact could be drastically reduced. Can you explain how precision fermentation works for our listeners?
Sure, absolutely. I mean, precision fermentation is a really fascinating area of research right now. So the works that we're doing with whole genome sequencing and proteomics and metabolomics is just led to just opening a whole new chapter in what we're
Hmm.
doing with fermentation. So, what is precision fermentation versus conventional fermentation? So, people have been fermenting foods for thousands of years, right? Relying on yeast and bacteria to process raw ingredients and to turn them into edible foods, everything from beer to bread to kimchi. Okay. So those microorganisms only ate certain things.
Hmm.
And from a metabolic standpoint, they only produced certain things. I mean, they're very useful because they were able to break down cellulose and hemicellulose into digestible sugars for humans, right? So they're able to take food which was not inedible or provided very little nutritive value into things that do provide nutritive value for us when we consume them. So, but because it was, we kind of gather these wild strains, and even after you get into the, Louis Pasteur days of breeding new strains of yeast to make better beer, it was still kind of a old school breeding stuff to get better fermentation cultures.
Hmm.
Now, though, we can, thanks to modern food science, we can really dig into the cellular, molecular, microbial ecology. Okay, I mentioned whole genome sequencing, microbial community, metabolomics, and so on. And we can specify what metabolite or nutrient we want to produce, and we can design a multi-species microbial ecology that will produce it. And we can do that based on specific inputs, right? So, I mean,
Hmm.
bacteria out in the wide world, bacteria almost never live alone. You never have one species of bacteria. You have got multiple species of bacteria that are all working together in conjunction with other kinds of fungi
Oh.
and so on to produce lots and lots of different kinds of metabolites coming out. And so now we have a much greater understanding of that multi-species microbial ecology.
Hmm.
Okay. The way I like to think of it is if you imagine, Little House on the Prairie, and you've got families, settlers, they're going out into this wide open space. And if you've got 50 families out in some state, they establish a town, and that town behaves in a certain way. The behavior of that town will change dramatically if you introduce one person that comes in and opens up a church. And now the behavior of the town changes. And the behavior of that town will change dramatically if you have one person that comes into town and opens up a casino.
Hmm.
So, and if you have a church and a casino, then even though they represent only very minor components of the overall population, they create this incredibly complex interaction of metabolomics, consumption of behavior, let's say, so that you get this complex inputs, complex outputs. Up till now, I would say the last 10 years, a lot of this stuff has just been so complicated, such a black
Hmm.
box. We really have a good understanding. But now we've got a much clearer understanding of that. So we can take side stream products from food processing, we can waste stream products from food waste stuff, and we can lean into these precision fermentation for designed communities of microbes, give them the feedstocks that we want, and we can get valuable nutrients out the other side. So, I mean,
So what can we make? What can we
uh,
make?
well, if you want to make lactic acid, you want to make certain kinds of vitamins, you want to make certain kinds of proteins. If you want to convert, do conversion of things, there are a lot of things that are, useful in the food industry. You can make surfactants, you can make flocculants. I don't know, flocculants are stuff that if you got a bunch of this, solids suspended in material, you add a flocculant, it causes it all to clump together and drop out, so you get clean water out the other side. Uh,
So to put a finer point on it, we can make both food materials and materials that help us process a variety of things, including our waste.
Correct. Yeah, absolutely. Absolutely. Flocculants are used very extensively in wastewater production,
Hmm.
where you've got a lot of suspended organic matter or you've got a lot of other suspended material. You add in some flocculants and all that stuff clumps up and it drops out. And then it really, really simplifies the process of filtration and cleaning that water so you can return clean water back into the environment. And from a food standpoint, when you're producing, stepping away from say the wastewater stuff, but let's say that you're producing beer, or you're producing wine,
Hmm.
or you're producing yogurt, you're producing some other kind of a liquid thing. You might add one of these ingredients to cause oil droplets to remain suspended, or to cause sediments to drop out, or to give you better colors, or to give you different kinds of nutrients, or different kinds of vitamin production. All of these things can be the result of precision fermentation because we have that understanding of what the microbes are doing, what they're eating, and what they're producing. And I mean, there's a lot of research that's going into this right now to work out those molecular details, those metabolomics details, and then position it so that it can be scaled up and then put through its paces. Let's get that cost engineering analysis. Let's scale it up. Say, what's it going to cost? Where are the weak points? Where do we need to improve this? So that you can then feed into developing a business case around it, selling a product, and working on consumer acceptance. You get stuff out in the real world.
Going back to simplification. So what we're talking about is that we have been farming as a species now for 25,000 years with macro level cattle and products.
Mm-hmm.
Where we are moving now is micro scale relationships with nature that allow us to produce our food and other forms of materials supplies.
Right, right. So conventional agriculture, there are, let's say maybe 20,
Hmm.
20, 25. Well, let's be generous. So there are 50 species of
Hmm.
animals that we use in animal agriculture. And these animals are used to take things that we can't eat and turn them into things that we can eat, or
Hmm.
things that we want to eat, right? So you got cows, you got chickens, you got hogs, you got goats, sheep, and so on. But it's a relatively short list.
Yeah.
So if you're going from conventional vertebrate animals to insects, there are thousands and thousands of species of insects, only a small handful of which have really been looked at for optimization. Each one of those are capable of different kinds of metabolizing different sorts
Hmm.
of things, and they live in different kinds of communities. And when you then go to the microbial world, you've got millions of kinds of organisms that you can use operating. And if you look at the different kinds of microbial community combinations, the numbers scale incredibly, like trillions of different kinds of combinations of microbial communities that you can create and cultivate and use in these bioreactor kind of environments, each of which eats different things and produces different things. The goal is always to produce food and nutrients and food processing materials and so on that are safe, healthy, wholesome, available, and sustainable. And when you start to lift your eyes up to the skies and see all the possibilities out there, it really becomes, I don't want to say magical because I'm a scientist, right? But it becomes amazing to think about all the things that we could do if we were able to lean into the kind of science that would allow us to take advantage of all these different things. And,
It
and
is
again,
magical in the sense that Arthur C. Clarke meant it, which
it,
is any sufficiently advanced technology appears to be magic until it becomes normalized.
and so just imagine that you had some kind of a tank and you put in garbage and you get out gumdrops, right? Wow, that's magic. Well,
Mhm.
okay, obviously we're oversimplifying because there's all the various steps involved in that. But at IFT, what we're trying to do is we're trying to bring together all of the different food scientists and food technologists that have the knowledge that will allow us to do some of those things, to increase the food supply, to make it safer, make it more wholesome, make it more available, and to do it in a way that people can access and that they can have knowledge and confidence in using.
Another topic in the paper was cultivated meats. And this is something that in 2013, and we've had folks on the show talking about this several times, a burger in 2013 grown in the lab cost about $300,000 and it's under $40 today. And we're talking about meat that is coming out of a lab, not something processed to appear like meat. Where's that
Yep.
technology realistically today? Because that number is 10 years old.
It's getting better. I don't recall like exactly what the latest numbers on that, whether that's gone, down to $20 or $15 or where it
Mhm.
is. But this is one of the big areas that another area of technology that people are looking at that, you know, Arthur C. Clarke would have maybe predicted this back in 1955, but I believe it was Winston Churchill who actually predicted this. I'm trying to remember the quote, but he said, someday we're gonna be able to raise chicken legs without having to raise a whole chicken. And so, yeah, are we there yet? Well, we're not quite there yet. But there's been a lot of work that's been done on this cellular agriculture
Mhm.
right now to create meat cells, whether they're from pork or beef or chicken or fish, to grow these out so that they look, taste, perform, and smell like I don't want to say like the real thing because they are the real thing, and this is ultimately what it
Mhm.
is. But like conventional, traditional things that everybody is used to. There's part of the work that's gone into it has been to show that yeah, can you do this? Well, you can do it. You can produce these, and it looks like a burger, tastes like a burger. But can you do it in a way that's going to allow you to make that available to people so that it's not just a very very, very billionaire niche novelty product. That's part of the challenge. But I think that's part of the challenge with any kind of food technology innovation, Mitch. You start in the lab and you begin with saying, well, is this even possible? And once you've demonstrated that it's possible, then you start to develop that out and say, well, how do we lean into some of the engineering stuff to
Mhm.
make it realistic? And the realism falls in what people will want to buy, willing to buy, or so from a cultural acceptable standpoint, from their expectation of what food is, what how much it's going to cost, how available it's going to be,
Mhm.
and then what are the inputs necessary to create it, right? And that'll dictate a lot of the kind of the overall feel and the overall landscape in which these new products are going to operate.
It's a data problem to a very great degree. And one of the areas the paper goes into in depth is how AI-driven supply chain modeling and various forms of traceability can perform as climate adaptation tools. Where are those technologies actually deployed today at commercial scale that you might be aware of? And do you have any evidence that they're actually reducing emissions, reducing the overall impact of our food system on the planet?
Well, so a lot of the AI tools, I mean, I can tell you what the AI tools are doing now, and probably by the time this show airs, they might have changed,
Oh
right? Because
yeah, obsolescence is an hourly thing today.
AI tools are moving so fast. But AI is in one of those areas where if you want to know how much something costs or how much water you're using to produce it or how much of an impact you're having, being able to go into the data and ask sophisticated questions of complicated data sets is one of the things that AI is very, very good at. Okay. It does it quickly so you can get into what are the trends, what are the key points, what are the key pain points for where do we need to lean into and do more research and do better so that we can get a better outcome on the backside, right?
So we're just beginning in that process, along with the leaps that we're taking in various forms of fermentation and cellular agriculture. Can you paint a picture where you think the food system should be in 10 years in order for us to start to transition through the climate era?
The food system should be more holistic.
Hmm.
That I think is one of the things that will make a big difference in terms of our overall ability to respond to issues of sustainability. And it encompasses everything that falls under that. So right now, there are disparate areas of science and disparate areas of scientific inquiry that are, a little bit isolated. You know, I like to make the joke: if you got an apple on the tree and you've got a bacteria on that apple, it's a plant pathology problem. But as soon as the apple falls from the tree, well, now it's a food microbiology problem. And you need to get the plant pathologist and the food microbiologist talking to each other so they have that kind of understanding of the continuum. I think if we're going to respond to these large, complicated problems, then we need to have a greater connection between different areas and different scientific disciplines so that we can adopt and create that holistic approach.
Well, and IFT is doing a lot of work to articulate that. You mentioned at IFT.org earlier.
Mhm.
How do people follow your work? What do you recommend they do to keep track and keep at the cutting edge so they understand these things as they evolve?
Well, you can join IFT, first of all. That's, that's an easy one. If you go to ift.org, there's membership information right there.
Mhm.
We're a great group of folks, very active and very involved in all kinds of different areas for food science and food technology. But we make a big effort to publicize what we're
Mhm.
trying to do. The science that's done, the research that we connect when we have all the different areas, people that are working within the field of food science, so they come to the meeting and they connect with us. All the people from academia and industry and government that are members of IFT. When we connect them all together, we publish like the white papers that we're talking about right now. We do press releases, we do commentary on different things, we engage in media responses, all kinds of stuff. Some of this is kind of hot button issue of the day, and others times we comment on larger scientific issues, big landscape issues that are going to be affecting us now and tomorrow and the next 20 years.
Well, Brendan, thanks. This has been an eye-opening conversation. Really interesting.
Well, Mitch, I've had a lot of fun with it. I really appreciate your having me on the show.
Welcome back to Sustainability in Your Ear. You've been listening to my conversation with Brendan Niemira. He is Chief Science and Technology Officer at the Institute of Food Technologists, the Chicago-based scientific society that has connected food scientists across academia, government, and industry since 1939. You can learn more about the IFT's work and read that new white paper that we discussed, Food Science and Technology Solutions for Mitigating and Adapting to Climate Change, at ift.org. Most of the climate fight in food is happening in the middle of the supply chain, where the public has almost no visibility and the policy debate keeps looking somewhere else. Brendan described a three-legged stool for food safety: exclusion, containment, and eradication, noting that as the planet warms, exclusion gets harder. That's because pathogens can travel further, persist longer, and show up in places they didn't used to. And that single observation reframes food safety as climate adaptation work. And it lands at exactly the moment when federal research capacity at agencies like the USDA Agricultural Research Service is being thinned out. Roughly a quarter of global greenhouse gas emissions come from the food system, and the people best positioned to redesign safety and efficiency at the processing, packaging, and distribution layers of our food system are being asked to do more with less. The first idea worth elevating from our conversation is the distinction that IFT keeps insisting on between food processing and food formulation. In other words, the question of what you do to the ingredients instead of what's included in the ingredient list is critical to the sustainability and health outcomes of what we eat. Brendan is right that the thumbs up, thumbs down approach we see in federal decisions these days may drive engagement, but it confuses policy. The Maha Commission's framing treats processing intensity as the problem, and that collapses a category that includes both deep-fried snack cakes and shelf-stable beans, both ultra-formulated soda and pasteurized milk, into grossly simplified yes, no, us versus them choices. And that's not what we need right now. That's because the climate consequences matter. Many of the technologies that extend shelf life, cut food waste, and reduce cold chain energy demand involve processing. If we regulate processing, treating it as a proxy for harm, we hobble some of the most useful tools we have for cutting the system's environmental footprint and improving its safety. IFT's response: to define nutritional quality by what the food does in the body, not by how it was made, is scientifically defensible. It is also, as Brendan acknowledged in his own way, complicated by the fact that the IFT's membership includes the companies whose products would be reclassified under any new rule. The second idea that I want to dig into a moment is microbial agriculture as a structural shift in what farming means. Farming in 50 years will be as unrecognizable to us as today's agricultural system would be to a farmer plucked from 1890, when 43% of Americans worked on farms. Humans have domesticated perhaps 50 animal species over 25,000 years of agriculture. And Brendan's point is that precision fermentation, built on whole genome sequencing and metabolomics, opens up access to trillions of possible microbial community combinations. And precision fermentation can take side streams and waste streams from existing food processing and convert them into all sorts of things: dairy proteins, food ingredients, even in water treatment systems. That's a circular bioeconomy story, and that's one that all of you who've been listening for years are aware of. It aligns with the case made by my recent guest, Jasper Steinhausen, that sustainability should be a profitability lever, not just a cost center. We have the opportunity to invent entire new industries here, folks. And the third idea is one that we return to most often, and that's holism or thinking in systems. The climate problem doesn't respect the disciplinary boundaries that scientists observe every day. The IFT white paper's call for AI enabled supply chain modeling sits right inside, right at the center of this argument. And that's not because AI is magic, but because the food system data that we rely on is fragmented across many actors who don't currently talk to each other. And pulling that data into a coherent picture is the kind of work that modern LLMs are actually good at. The critical issue here is that federal research cuts don't just slow individual programs, they erode the connective tissue between disciplines. And the connective tissue is where climate adaptation has to happen. Innovation is the product of diverse solutions being combined in new ways, and the most unexpected connections often yield the greatest impact. So we need more cross disciplinary discussion, not less. The food system is being asked to feed 8 billion people under conditions that it wasn't designed for. With less federal science capacity, a public conversation that mistakes processing for poison, and a set of emerging technologies that are scientifically ready, but they're culturally challenging, as our discussion about insect protein showed. So here's the headline to remember from my conversation with Brendan Niemira. IFT is making the case that food science is climate science. And we're going to be watching how that argument lands as the MAHA debate continues and as the 2026 dietary guidelines evolve. Hopefully, they won't mutate too much. Hey, if this episode gave you something to chew on, please share it with someone in your world to make new connections possible. And would you consider leaving a review of Sustainability in Your Ear on Apple Podcasts, Spotify, iHeartRadio, Audible, or any of the other purveyors of podcast goodness where you can listen to the show? You folks are the amplifiers that help spread more ideas to create less waste. And our archive of more than 550 episodes it's there anytime you want to dig deeper. Thanks, folks, for your support. I'm Mitch Ratcliffe. This is Sustainability in Your Ear, and we will be back with another innovator interview soon. In the meantime, take care of yourself, take care of one another, and let's all take care of this beautiful planet of ours. Have a green day.